Okay, in this presentation we are going to look at continuous random variables. Here we have a continuous random variable x and it has the following probability density function. F of x equals c times x minus 1 to the power of 4 if x is between 1 and 2 and 0 otherwise. So c is a constant and what we have to do is find c and the expected value of x. So this is what we can start off with here. That this is by definition the integral from minus infinity to infinity, that should be a minus there, of f of x dx is equal to 1. Now outside this range of values the integral will evaluate to 0. So essentially what we do is look at this particular range of values here and get the integral for that, the definite integral for that. So essentially what we should get here is 1 is equal the integral from 1 to 2 of c times x minus 1 to the power of 4 dx. Okay, now what we can essentially do there is just treating x minus 1 as x. Essentially that's a straightforward enough integration. So what we end up with is 1 equals c times x minus 1 to the power of 5 divided by 5, integrated from 1 to 2. Okay, so when x is equal to 2, that's simply x minus 1 is just 1, so x minus 1 to the power of 5 is 1 to the power of 5, which is just 1. Okay, so we have when x is equal to 2, we end up with c divided by 5. When x is equal to 1, when we evaluate that, it just evaluates to 0. Okay, so the integral is c over 5, and that has to be equal to 1. Therefore, c is equal to 5. Okay, so that is our value for c. Now, the expected value of x, by definition, is the integral from minus infinity to infinity of x times f of x dx. But again, we concentrate on the interval from 1 to 2 because anything outside of the interval is evaluates to 0. So we can just disregard it and just look at that part there specifically. So, knowing that c is equal to 5, this becomes the integral from 1 to 2 of 5x times x minus 1 to the power of 4 dx. Okay? So what we have to do here is something a little bit, unusual. Essentially what we can do there is express x minus 1, or 5x as x minus 1 plus 1. Okay, so essentially an integration by substitution thing, essentially was what we're doing. So in the first instance, what we have there is 5, the integral of 5 times x minus 1 to the power of 5 dx. Okay, essentially that part there. And the integral of 5 times x minus 1 to the power of 4 dx, which is related to that part there. Okay, so to see what has happened there, this just it requires a little bit of guile. So you have x minus 1 and 1, and when we multiply that by x minus 1 to the power of 4, we get these two different expressions here. Okay, just requires a little bit of guile. It looks weird, but if you sort of think about it in reverse, it makes sense. And quite often you'll have to do this in mathematics. Okay, so what we have is the integral of from 1 to 2 of x of 5 times x minus 1 to the power of 5 dx, okay, which we know to be that, and the integral from 1 to 2 of 5 times x minus 1 to the power of 4 dx. Now actually we've actually evaluated that already. We know that to be 1, okay, because essentially what that is the integral of f of x dx. Okay, and by definition that's 1. So essentially we don't really have to do anything there because by definition it's 1. So essentially what we have to do is look at this part over here. The integral of that is 5 times x minus 1 to the power of 6 over 6, integrated from 1 to 2, and then the plus 1 there, don't forget about that. That works out to be 5 over 6 because when we integrate that at the lower bound, 1, it's 0. So when we integrate it at the upper bound, it's 5 times 2 minus 1 to the power of 6 divided by 6, which is 5 times 1 to the power of 6 divided by 6, which is essentially 5 over 6. Okay, so it's 5 over 6 plus 1, that is 11 over 6. So what was the tricky part here was actually this bit here, going from 5x and splitting it up into x minus 1 and 1 so that you can have these two expressions here. Okay? And knowing that you save yourself a bit of work by knowing immediately that that was going to integrate to 1.